I guess we're here to talk about Avalanche. I'm moderating, I guess. So I don't know if there's like, topics or questions that people had. Oh, Amaury.
Hey, hello. Sorry for that.
Tyler here is too. Great.
There's Tyler.
I was just trying to kill time before you guys showed up. So yeah, we're talking about Avalanche. I'll moderate, I guess. I don't know. I mean, I don't have a strong agenda or anything. I just thought maybe we could start out by everyone sort of introduce yourselves a little bit and go into like the history of Avalanche, like where it came from, what we're even talking about, and what it is. So I don't know who'd like to start.
Chris, do you want to start?
Yeah, I can go ahead. So Avalanche is a consensus mechanism that there was a paper that was dropped on the internet by anonymous authors, Team Rocket. I don't think we know who they are unless Tyler has some insight there. But it was picked up and kind of promoted by Emingun Serrer, who's been very helpful to us in the BCH community. He's an academic, I believe, at Cornell University. I'm not sure if he's still there, but who researches like consensus algorithms and things like this in the space. And so as a consensus algorithm itself, it's kind of like a halfway point between, say, like Nakamoto consensus and kind of classical consensus, and it has some interesting properties to it. And they're interesting properties that, we first started kind of throwing around the idea of potentially using Avalanche in Bitcoin Cash for something called PreConsensus a few years ago. We were always having discussions about things like related to PreConsensus. So like, for example, weak blocks is sort of an example of something that could be considered a PreConsensus, and the weak block concept has been around for a very long time. But the idea behind Avalanche, when that came out, it's pretty interesting. It has some potential advantages over weak blocks in that it could be even faster in terms of essentially confirming or pre-confirming transactions. And so but there's also some complications in like, how do you get this into Bitcoin Cash? How does it interact with the underlying Nakamoto consensus and this sort of thing? There's also the potential for using Avalanche for sort of finalizing blocks. So, when we had the big hash war with, that it was called, with Craig Wright and BSV, they were threatening to, do like reorg attacks against the Bitcoin Cash blockchain and this sort of stuff. And so at that time, ABC put in this 10 block reorg protection, like it won't reorg past 10 blocks in an attempt to try and like thwart that sort of attack. There's positives and negatives, trade-offs to reorg protection like that. And so something like Avalanche could potentially be used as sort of an alternative to that type of 10 block reorg protection, where you can sort of finalize blocks as they come in and prevent those sorts of attacks. And again, there's different sets of trade-offs and things that need to be analyzed in that sense. So that's kind of where we are. I mean, some work has been done towards writing implementations and kind of some small scale tests and stuff like that, but nothing has really gotten to the point where we're, even really kind of capable of putting forward like a formal spec or prototype that people can analyze and test and that sort of stuff.
Yeah, that's a good summary. Maybe I'm gonna add like a bit of history that a lot of people don't know, but as Chris pointed out, the idea of PreConsensus in BCH is older than Avalanche exists, and we were talking about, with various ideas. And notably at some point, just before the paper came out, with Séchet, we were talking about an idea that is effectively similar to what Ripple is doing, but not broken. So effectively, like, we were like, okay, Ripple, those guys, they say that they can confirm transaction in like a few seconds, right? So we need to look at how that works and what if there is something in there that we can reuse, and if it's broken or not as well, actually. And so what we figure out is that they have something that works if you make some assumption about the topology of the network that you actually cannot make. And so therefore it's busted per se. But we also figured out that by modifying the protocol and adding some level of randomization, we could make it work. And so we start, like working on that. And then the Avalanche paper came out, and it was basically everything that we were working on, but better and simpler. And so we're like, all right, our stuff is trash. We can just like move on and use Avalanche instead. Because this was really, like, assuming infinite iteration on our ID, this is probably where we would have ended up, assuming we are talented and everything enough to get there. So yeah, the Avalanche paper came out, and this is actually what we were trying to build, except we had a very crappy version of that. And so this seemed like very natural to shuffle a bit what we were doing to integrate Avalanche instead. The protocol, yeah, as you point out, it's a very interesting mix of what classical consensus and Nakamoto consensus can do. And it's very fast. So that's very suitable for PreConsensus, where we can do zero conf very, very quickly. That's a protocol contrary to classical consensus. You don't need to know the participant set ahead of time. You don't need to have it fixed in stone, and therefore you can have a permissionless system. And yeah, pretty much it fit the bill with many ways, in many ways. And so the more then there is this idea to do it for zero conf, but the more you dig into it and the more you realize that there is actually a ton of stuff that you can do with that goes way beyond just doing zero conf, right? You can do, as you pointed out, you can do reorg protection effectively, because one of the problems that you have with reorg protection is deciding what is a reorg, like a malicious reorg, and what is just, like a chain that you were not aware of. And with Avalanche, you can, contact your peers and run the Avalanche consensus to know that everybody is on the same tip. And so if everybody is on the same tip and suddenly there's a block that comes that it's not built on top of that tip, you know that it's a malicious reorg. So you can do that. You can do like a bunch of other stuff, but yeah, that's very promising tech. And that's just not science fiction. Like you guys, Chris, you have a prototype in BCHD. No, since recently we have a prototype that doesn't exactly do the same thing, or that would not be fun, but we have a prototype as well. Once you have something that works though, like, our goal, at least at ABC, our goal is going to be to evolve that prototype so that it can make peer discovery. Right now you have to connect all the peer manually with each other and tell them, oh, this is your Avalanche peer and this is your Avalanche peer. There is no like peer discovery on the network. So this is our next step. And then when we get there, we effectively have something that can work by itself. And this is when we want to ask our question, like what we want the protocol to actually look like. And this is where we can start talking about specs and stuff like that, right? But we're not at that point yet.
Yeah, that's a good starting off point. But before we start getting into where we're going with this, maybe I'll turn it to Tyler and ask him to kind of give his background and history with Avalanche also, and like what you've done and how you found out about it and stuff like that.
Yeah, sure. First, can you guys hear me okay?
Yeah, we can see you too. That's nice.
yeah, it's different. Cool. So I first heard about Avalanche shortly after, I assume after Amaury read the paper, told Chris about it, and then Chris posted a link to it in the Open Bazaar Slack. And I read it and I was like, I don't understand this. This is like not at all like what we're trying to do. And I really did not Like it just didn't make any sense to me at first, honestly. I mean, I understood the protocol. The protocol made a lot of sense, but at the time, I wasn't thinking about how I hadn't heard of the idea of pre-consensus or post-consensus. So I was originally thinking that the plan was that Bitcoin Cash was just going to wholesale switch to Avalanche. And I thought that was pretty, just a huge change in Bitcoin Cash. But everything else that ABC was doing seemed pretty much in line with what I thought Bitcoin Cash should do. So I thought that was really strange. So I started digging into Avalanche and pre-consensus and really trying to wrap my head around this idea that Amaury was proposing. And the more I got into it, the more I realized, like, not only is it totally in line with what we want to do with Bitcoin Cash, but it's fundamentally like much less of a radical change than I think a lot of people think it is. There's certainly like a lot to the protocol and a lot to get right and stuff, but at the end of the day, there's this whole Nakamoto consensus is sort of optimized for these really long human time scales, where you know you have reorgs that may last like hours, whereas you know in typical computer networks you want to make decisions in milliseconds or seconds. And so Avalanche really kind of fills the gap between what Nakamoto consensus can provide at like really long timescales and the kind of features and behaviors that we need to see on the network on a much shorter time scale to make things like zero conf safer or to protect against reorgs. So like recently, you know, there was a Bitcoin Gold 51% attack. It was ongoing for a long amount of time, and everybody in the community had to decide on a block that they were going to agree on to reject the 51% attack. And it was a very social process. They had to update the code. Everybody had to download it, install it. Miners had to eventually switch sides. So with something like Avalanche, you can make these decisions in, you know, a second or less than a second, instead of it being like a days or weeks long process. And ultimately, I think, especially with Bitcoin Cash being a minority proof of work chain, I think this is something that like we really need to look into if we want to make Bitcoin Cash successful in the long term. So that's kind of why I went all in on it personally.
This just happened to ETC as well, either yesterday or today. They got like a 60K reorg, 30K block deep reorg yesterday or today. I haven't been following the details because ETC, Ethereum Classic.
Oh, ETC. Okay, they said BTC. I was gonna say.
No, ETC. Yeah. No, BTC. You'd hear about it in the news, maybe, Evan.
But, like one thing I'm curious about is just to let people, because we talk a lot about the advantages. I guess my way of thinking about, maybe I'll give an analogy and throw it out there and see if you guys think it makes sense or not. Like my mental image of it, it's kind of like people at nighttime on the beach sitting around a campfire. That's like my analogy of Avalanche. So like people talk around the campfire and they can all come to consensus on what's going on and what's not in the campfire. Like people can wander in from the beach and join the circle and everyone knows what's going on. But if someone new comes into the campfire and says, hey, what happened like 3 hours ago? Then if it's all different people around the campfire, because they all came and went, the people could like tell them, could like make something up or lie to them on purpose. So is that, whereas like proof of work, it's like someone's like etching it down on a stone tablet or something. So when you show up later, you say, oh, what happened 3 hours ago? Someone can say, oh, look, we marked it all down on this stone tablet.
Yeah.
Right? And then you have some trust of the history. So is that like, because we talk a lot about the advantages of Avalanche, but like the part of etching the history in a reliable way, is that accurate to say that that's kind of like a downside of it?
I think this is exactly it. And I think this is why I have some reservation, though it seems to be working very well for them. But I have some reservation about the work of Avalab, because they use Avalanche exclusively, and so they are making that trade-off. They are making the trade-off, if I'm going to use your analogy, that we're going to use only the campfire, and so so it becomes very difficult to verify the history. Like at some point when you join the campfire, you're going to have to trust someone to tell you, like, here is what happened at that campfire before. And then you are in the campfire and you can talk to everybody. So you can verify from that point onward, but verifying the history is a bit challenging, right? So if you have the campfire plus the stone tablet, I think this is a better system.
Yeah, so I mean, it's all trade-offs, right? There's different properties for different consensus algorithms. Bitcoin and Bitcoin Cash, for its entire history, has enjoyed two properties that I think a lot of people don't really think about too often: objectivity and non-interactivity, which, you know, we don't need to get like too technical. I think the way Amaury stated it once was pretty good, which is that like Avalanche is a really great consensus algorithm, and then Nakamoto consensus is like really easy to tell people about. That Nakamoto consensus is easier to communicate to the world than Avalanche. Personally, I think this is an artifact of just the fact that Avalanche is new and what was created with different trade-offs in mind. We can create interactive proofs for Avalanche consensus, similar to the way Bitcoin Cash is planning to do it with Nakamoto consensus. It's different trade-offs. Certainly for Bitcoin Cash at this point, sort of the social contract, if you will. I know it's probably not a super great phrase, but I mean, we have Nakamoto consensus and proof of work. We're not going to get rid of that, right? And so while we have it, that's a perfectly fine way to generate these basically non-interactive and objective proofs for people. For a different network, I think personally I think it's an interesting and good trade-off to try to make for us at Avalabs on the Avalanche platform. But for Bitcoin Cash, certainly having these Nakamoto consensus proofs, essentially, of the Avalanche consensus, I think is important for the existing community and the properties that we've enjoyed for the past 11 years.
Yeah, I think that's even more important than like sticking religiously to proof of work or whatever, is that the system has some characteristics that user expect, and they are in the system because they like those characteristics. So we need to keep those characteristics effectively. And in the case of Nakamoto consensus, that you can verify the history and you can provide like reference point with Merkle proof about what was in the blockchain without downloading the whole blockchain. You can just follow the block headers and see that. And then you can track the longest chain to know which chain of header is the right one. That provides a lot of information without knowing the whole history, if you have someone that knows the whole history that you can talk to.
Yeah, so there's kind of like, yeah, so say the user experience of you just having your phone, you turn it on, open your wallet, and then you know what happened is what you want to preserve.
Yeah. Well, not only you know, but even though many wallets don't actually verify anything, they trust like whatever the server says, but you can build wallet that verify most things. And not only that, but like some wallet like that exists, like the Electrum wallet, for instance, is going to verify a lot of stuff by itself.
One question I had about Avalanche, like recently, a bunch of people from Avalabs have been talking about how it's hard to implement, and there's all kinds of corner cases and stuff like that. Like just my impression is that Avalanche does seem a little complicated compared to Nakamoto consensus. I guess it's just maybe just because I'm more familiar with Nakamoto consensus, but maybe could someone, Tyler or I don't know who, talk a little bit about that? Like what
maybe Tyler can talk about that, but I would like to
or Amaury, sure,
tweak something in the question if you wish,
yeah, go
because
for that first.
Avalanche is not complicated. Actually, it's remarkably simple, but there is a bit of a language twist that, language trap that people tend to fall into. It's confusing like easy and simple. And if you want to take like one of the like most striking example of that would be general relativity, right? Like general relativity is like extremely simple.
Yeah.
And yet, for anyone who's worked with the equation, it's extremely hard. It's not easy, right? But it's simple. And Avalanche is one of those things. It's extremely simple, but it's also not easy to implement correctly. And so maybe Tyler, you can talk about that a little.
Yeah, no, I think that's a great place to start. Avalanche is very simple, but simple doesn't necessarily mean easy to get right. So personally, in my experience, the trickiest thing that I found that introduced issues when I was working on writing my Avalanche implementation was that because Avalanche is this interactive consensus where you're polling your neighbors to see what they think, the communication becomes part of the consensus. So we talk about consensus rules in Bitcoin, and it's stuff like, the block has to be less than 32 megabytes, or transactions have to have signatures. And these are all things that your computer can pretty easily just, run some simple computations and check locally. It's universal, no matter what computer is doing this verification, it should be the same. And that's totally independent of how you get the block itself, whether it's on the peer-to-peer network or a Blockstream satellite, or somebody emailed you the raw bytes or whatever. But with Avalanche, the actual networking affects the consensus decisions that you arrive at. So the protocol that we use for how I talk to Chris's node or Antony's node and pull them, the order in which I pull them, all those things can potentially affect the outcome of the consensus. So I would say there's for me, the trickiest part to get right is that there's just many more, effectively, there's a lot more consensus rules that are sort of, I guess, more emergent, maybe is a good way to put it, versus like a list of like, these are the rules that we want in a block. It can't be more than 32 megabytes. All transactions must be signed, that kind of thing. With Avalanche, you kind of get consensus rules thrust upon you based on how you do your networking. And so at least from what I've seen, that's a big source of issues.
Of that, so is like someone how quickly they respond or something like that? Does that affect, like what is it that affects the networking properties?
Yeah. For instance, you may end up polling the same guy again and again and again because that guy is the one that answers the fastest to you. Right? That, like that's a very obvious version of the problem, but there are more subtle versions of that problem that can arise depending on how you implement your stuff. But effectively, if you do that, you are not running Avalanche. You are running some degenerate version of it. That's not gonna work. So you want to poll like everybody, right? But you don't want the whole network to stall if one of one of the node is down, right? So you need to have like some margin there somewhere, like if one of the guy doesn't respond to me, then, I'm going to consider that this guy is offline and continue to run the process, right? But what happens if I poll with, like 8 guys and 7 of them are offline, am I going to poll the same one again and again? I don't want to do that, right? So there is like a whole set of stuff that you have to be very careful at that level.
Yeah, we've spent a long time. Some people on our team, I think, have done a really great job at putting together a testing framework that we can use to test these kinds of emergent rules out, spin up a bunch of different nodes and have them interact with each other in different ways. And I think that we found a lot of these corner cases and fixed them, but a lot of them are not things that you can just set out from the beginning and enumerate like all of the potential issues that you're going to run into, like you can with a lot of other problems, I think. So a lot of these problems just have to be solved by, you know, straight research and development power. And so it really takes a lot of investment to get right. It's not something I would want to just rush into. I would really want to see a solid implementation and really battle test it before trying to jump into it, just because there's all these kinds of tricky corner cases.
Well, I guess our panel, I guess we have about 3 minutes left, so maybe I'll just go around the table, starting with Chris, and just wrap up on like, where do you see what do you see for BCH, for Bitcoin Cash? Like, how do you see Avalanche in the future, and what could things look like with Avalanche?
Well, I think you know, we probably want to get to a point where the Avalanche, kind of a little bit like what I had in a little demo that I created with software a little while back, where it's running but not actually being used for consensus, and so we can collect data and kind of see how it's performing in terms of transactions or blocks and that sort of stuff, and kind of get a better idea on what it would actually look like to run on the network, you know, before we consider any you know, kind of formal proposal to incorporate it. I do agree that there's the edge cases in Avalanche tend to be pretty nasty. Like when I was thinking about, you know, how to use it like pre-consensus only, there was a lot of edge cases due to like race conditions that were kind of hard to deal with. And, you know, if you introduce the post-consensus on top of it, then you have sort of a mechanism to kind of handle those race conditions and what have you. So, you know, we'll kind of have to see how it goes, but it is, I mean, in a sense, it can be considered a big departure from how things have currently worked, but also potentially better too, you know, so we'll have to evaluate it, I guess, as we go.
Do you want to add anything, Amaury? I'll give you the last word. We have like 1 minute left.
Well, I don't know. I pretty much agree with Chris, so maybe someone else wants to say something.
Well, Tyler can have the last word then.
Okay. Yeah, no, I mean, I do largely agree with Chris. I think it's an important point that pre-consensus is very exciting, but we really have to do post-consensus as well if we want things to work out. So I think we need to keep that in mind as well. But I'm really optimistic about what we can do with Avalanche on Bitcoin Cash. I'm excited to start doing some tests on our Avalanche platform that we developed at Avalabs. I've tried out a Bitcoin Cash VM so I can use our network to make decisions for Bitcoin Cash. And I think that there's a lot of really cool stuff that we're going to be able to do in the future with this technology.
Sounds good.
Cool.
Well, thanks, guys. We're right on schedule, George.
Yeah,
Turn it over to
precise, like the developers you are, the technical minds. Yeah, great panel. Thank you so much. Amaury Séchet and Antony Zegers of Bitcoin ABC, Chris Pacia of BCHD, Tyler Smith of Avalabs. Outstanding.
All right.
See you later, guys.
Thanks, guys. Yeah.
Talk to you.